Morning friends, welcome to ChatGPT Network Automation Part 2. Simplify your networking task using the Ansible. In part 1, I demonstrate about the Python netmiko, how to automate all our tasks and simplify it using the ChatGPT. Even if you don't know ABCD about the network automation, but if you provide your requirement crisp and clear to the ChatGPT, so you get the programming output suitable or according to your need. So today we are going to automate our task using the Ansible. Before going to lab, just we will see briefly how exactly Ansible works. Ansible is completely free version. It is very simple to understand. Ansible has the inbuilt multiprocessing capability where it can establish the SSH session with the multiple routers and get the output simultaneously from all these devices. So that helps us to fast or automation task or get those data quickly. So next one behavior is the idempotency. Means let's say I have the playbook to configure the OSPF in my network. I run the playbook first time. I got the result everywhere OSPF has been configured properly. But if I run the same playbook again, so in the result it will show me the zero changes. Means once you run the same playbook again, Ansible management will try to get the information from the routers and it will try to compare the states with the previous state. If the Ansible management sees that already changes has been made on this router using the earlier script or using the earlier run, then it's not going to make any further changes in the network and it will say that zero changes. That behavior is called as a idempotency behavior. Third most important point is agentless architecture. If we talk about the chef and puppet, those needs the agent on the router switch or your server, which will pull the data from those agent. But for the Ansible, we don't need any agent on the router switches or servers because it is completely relying on the SSH as a underlying transport protocol. That's the reason we don't need any additional agent on the routers. So the Ansible management pulls push this script onto the routers and fetch those data and then displays you the result. That's why we call that Ansible is work on the push model because we are pushing the script on the routers to get those data. So there are so many advantage or good parts of the Ansible, but I have just covered the few important points. So to run Ansible, we need few more stuff, and main important thing is that ansible.cfg file where you store all of your settings related to Ansible playbook in the ansible.cfg file. The second most important file is the inventory file where you store your router's IP address and other variables like user ID, password, and many more stuff. And then third most important is your playbook. That should be in .yaml format. So let's say you run the Ansible playbook command and then playbook name on your laptop. So Ansible management tool node comes into the picture, and first it will try to verify the ansible.cfg folder, cfg ansible.cfg file, where you will have the many mandatory parameters and many optional parameters. But most important parameter is the ansible.cfg file. So it will check that where you have stored the router's information. If it is local to the directory, then you just need to mention name. But if you have kept it somewhere in the other directory, then you need to mention that complete path here. So once the router figure out where is the inventory file, then it gets that data from the inventory file like IP address, connection type. So these variables I have mentioned in this inventory file. Then once Ansible management get that information, it tries to establish the SSH session with all those devices to fetch the required data. So this is very simple that we just need the three file ansible.cfg where you have provided all those parameters which you require to run for the Ansible playbook, and then you need to mention the file name where you have stored all the information related to routers. And once that Ansible management get that information, it's try to establish the SSH session with the routers. So this is how your ansible.cfg file looks like. So this is my inventory file. Name is routers underscore IP. And these all are the optional parameters, but this one is the mandatory one. And this is the fork value. So by default, router can establish the SSH session to the 5 devices by default. But if you need to establish this session with the more devices, then you need to modify this value. So according to this figure, it can establish SSH connection to the 8 devices. So next file is the inventory file where you have kept the all the routers information. So under this file all is on top, and then you can group your information So here I have grouped these routers based on the OS type. So here I have provided the router's IP address, operating system, username, password, and then Ansible connection. So Ansible connection, you have multiple options. Like here by default it is network underscore CLI. Then you can have netconf, resconf, and many other options are available there. So this is how the inventory file looks like. And then if you try to run the Ansible inventory graph, so you can see that all is on the top. So inside playbook, if you mention all, then that playbook is going to run for all the nodes. But let's say you just want to run it for the ISXR devices, then inside the playbook you can just mention this ISXR group name and it is going to just run for these only these two devices. So this is how Ansible create that list to execute or connect to that particular routers. It checks the connection, user ID and password, whatever information you have provided inside the variables, and then it tries to establish the SSH to the routers. So this is the sample playbook to just configure the OSPF on the XR device. So this indicates that it is the YAML file. Then playbook name, this is optional. Then you need to mention that inventory file name. So I'm just running on the ISXR device. Hence I have just mentioned the ISXR. Else if I need to run it on all the devices, then I'll mention all here, including Juniper and Arista devices. So this is the mandatory parameters here. Then inside playbook, it comes as a task. So you can have multiple tasks inside one playbook. Then this task name, this is optional, and this is the module name. This is mandatory. So to configure anything on the Juniper devices, the module name is isxr underscore config. But if you want to fetch any display data like show OSPF neighbor, so this module will be different for that. So inside module, you will have the configuration parameters, and then you are storing those result. You are passing that condition when router is running 641. Only that time configure this OSPF on that router. And then last line is to just display that output for that configuration. So first it is playbook, then this is task, then inside task, this is the module or function. So there are many use cases of the Ansible, but I have just covered few. So you can create the multi-vendor configuration using the templates, and Ansible can help you and simplify your task. You can deploy the configuration, you can get the data from network devices, you can perform the compliance check, and you can generate any report from the routers. Let's dive into the lab. So this is my ansible.cfg file where inventory file name is router underscore IPs, and then remaining these portion are the optional parameters. And this is my inventory file where I have stored the router's IP address. I have grouped them based on the operating system. So this is router IP address. This is the operating system. This is the user ID. This is the password. Then Ansible connection. So if we see the Ansible, I'm running this particular version here. And if we check the inventory, this is how the inventory list looks like. Where for this first router, these are the parameters: connection type, operating system, user ID and password. The parameter which I am passing here. And if we check the graph, so this is how it looks like. So for if I want to run the particular playbook for the all of the node, then I'll mention all in the host in the playbook. Else, if I need to run just for the few routers or the for particular operating system, then I can mention that group name. So the first task for today is to configure the OSPF on the Juniper node. So if we go to Juniper node first, there is no OSPF configuration here. And if we check the neighborship, it's saying that OSPF instance is not running. So let's try to configure the OSPF for the Juniper using the Ansible playbook. So for that one, let ask to use ChatGPT. Provide me Ansible playbook for OSPF configuration on Juniper for interfaces loopback 0, geeky 000, geeky 001, and geeky 002. Below is the inventory file information for Juniper device. Or just I'm copying that inventory file information, just providing it to the ChatGPT, and let's see how it reacts. So we can see here it has provided us the playbook, and then this is the information which we pass it to ChatGPT. So let's try to copy this playbook, create the new file using the OSPF Juniper config.yml. Let me paste this information, but before pasting, so here we don't need any configuration for the loopback because loopback is already configured. So we will remove this task here. So as we discussed earlier, we can have multiple tasks under the playbook. So you can see this is the YAML indication. So this is the start of the playbook. This is the task information where under the task we have multiple tasks provided. So let's remove this first task from here. We don't need it. And we just need the OSPF configuration on the Juniper device. So let's try to run this playbook. And to run this playbook, you need to run it using Ansible playbook, then OSPF. Let's see how it reacts. Okay, let's copy this error information and ask to the ChatGPT. It's completely depend on you. If the more crisp and clear information you provide to ChatGPT, then more clear information or clear program you'll get it from this ChatGPT. So let's copy this program for this one and then copy and paste. This time it has provided us the configuration in display set format. So this is the playbook, this playbook name. So host, it should be Junos because it should match with this one. Group, inventory group information. Then network connection type, network CLI. This is task name. This is the module for the Juniper config and this line is going to pass it. So let's see how it reacts. We got some error. So let's try to check with the chat GPT again. So you may get multiple errors. So you need to check continuously with the chat GPT until you get the final solution. So here, so you can see that it's asking us to change the network CLI with the netcon. So you can see the Ansible connection type. It's saying that use the netcon, and then it's asking us to configure that netcon SSH on the Juniper device. So let's try to modify those information. So let's try to configure the netcons set system. So what is that exactly? Set system services netcon SSH. We'll see the configuration. Yes, let's commit. And yes, we have configured the netcon on the Juniper device. And then let's modify our inventory file. And let's say here netcon. Let's try to run it. Yes, we are good. So you can see here it is okay and change has been made. If we run it again, we should get the change as 0. So as we discussed earlier, that item potency feature of the Ansible. So let's try to run this playbook again and see. So you can see that it says okay, but change is 0. So earlier change was 1. So let's go to the OSPF, sorry, on the Juniper and see the configuration. Yes, we are good. Here is the configuration. If we check the earlier configuration, If you see here, OSPF was not part of the configuration, now it is configured. And if we check the OSPF neighborship, yes, we got the neighborship with the neighbor devices. So this is the first task where we configured the OSPF on the Juniper devices. We can configure same way in the IOCXR or Arista devices. Let's review this Ansible playbook. So this is the YAML, starting of the YAML file, means indication of the YAML file. This is the name of that playbook, which is optional. This is the inventory file information, where if I want to run it for all the nodes, so I should type it should be all, means it will run for this playbook for all these devices. But I need for the Juniper devices, so I have mentioned this Juno's name here as a group. So that's the reason I am calling only that particular group name there. This is the mandatory parameters, and these are the optional parameters. This network CLI already we have defined in the Juno's inventory in the inventory file, and inventory file parameters takes the precedence over the playbook file, because here we have configured the netcon, and here if we define the network CLI, it takes the preference of this inventory file. Then it comes inside the playbook, it comes as a task, and inside the task it is module, and inside the module it is configuration or whatever task you want to perform. So next one is the we have done with the OSPF configuration. Let's try to verify the OSPF configuration on all the routers. So let ask to the ChatGPT, please provide me the Ansible playbook to check the OSPF neighborship status on ISXR, Juniper and Arista device. Below is the inventory file information for all of these devices. And then I'll just copy and paste this complete inventory file information. And let's see how exactly ChatGPT reacts here. So you can see the difference here. Earlier it was configuration, now it is command. So this is the playbook information we got. Let's copy and create a new Ansible file by name OSPF neighborship verification.yml. Let's paste this information. So this is for the YAML. This is the playbook information. This is the playbook information. This is the task, and then we have the multiple tasks. For this is the task for ISXR to verify the neighborship. This is the task to show that neighborship information, whatever information we captured here in this variable, it will show here in the second task. And same for the Juniper and Arista. In the first task, it is getting that neighborship, it is storing into this variable, and in the second task, it is displaying that status of that neighborship. So let's try to run it. Ansible playbook, then OSPF neighborship. Okay, we got some error here. So let's just simply copy and paste this information and ask to ChatGPT. So it had changed some information on the Juniper side. So let's try to copy this playbook, paste it. So it's trying to running the RPC because we are using the netcon here. So let's see. Okay, we got error again. Let's check with the ChatGPT. So you can ignore here because we are not using the Ansible Galaxy. Okay, so here in this, it has modified this one. Instead of RPC, it's using the different module now. So let's see if it is works or not. Copy, paste, save, and then rerun it. So if you see host all, that's the reason it is skipping for 17 and 16 because those are not ISXR. We are good with the Juniper and ISXR. So now it is running on the Arista device. We are good. So you can see here we good. Okay. And if you see the OSPF neighborship for ISXR, yes, we have neighborship with the Juniper device. For the last ISXR2, we have neighborship with the Arista device. And XR1, XR2. This is for the Juniper. We have neighborship with the XR1 and Arista device. And then on the Arista, we have neighborship with the ISXR2 and then Juniper device. This is how we can verify the neighborship and we can fetch all those data from those devices. So you can verify BGP status, OSPF, ISIS. So it's easy for the big network if you are running with the 100 or 200 nodes. So it's easy and even you can save this information in the files. So let's ask ChatGPT, please provide Ansible playbook to save OSPF neighborship information in the file. So now this time we will save this information in the file instead of displaying on the screen. It will try to save that information in the text file. So let's copy it and create the second file OSPF neighborship file .yml. Then paste this information. So we can verify the last. Let's check for the arista. So here we can see that it will run this particular command on arista. It will save in this particular variable, and then it will try to save that information in the this particular file name. So let's try to run this playbook. So we should see some files here. XR1, XR2, Juniper. Okay. And this is arista. So let's verify. This is the neighborship status on the XR1 device. This is the neighborship status on the Juniper device. This is the neighborship status on the, sorry, the second was for the XR2. This is for the, oh my bad, sorry. This first is for the Arista. This second one is for the XR1. This third one is for XR2. And this is for the Junos. So this is how we can save this information in the text file, and even we can club this complete information in the single text file. So now next, network automation we will test is to ping the all IP addresses which we have advertised in the OSPF. So let's check the Cisco routers and see what route we have. We have 1 2 3 4. So let's try to ping it. Let ask to ChatGPT. So it's a 10.1.1.1, 10.2.2, 10.3.3.3, 10.4.4 prefixes on ISXR, Juniper and Arista devices. Below is the inventory file information. Let me copy the inventory file information and paste it here. And let's see how ChatGPT reacts. But we got the program for the from the ChatGPT. So let's try to save it using the ping or connectivity test.tm. Let's try to see. I'm running for all the hosts. This is the variables information, means those IP address, and then each device is trying to ping all those IP address and then saving this result in this particular variable. And in the second task, it is displaying that one. So let's try to run the Ansible playbook for the connectivity test. So we are running this for ISXR, and the 16.16 and .17 is Juniper and Arista. We got output from the Cisco XR, but it is not in the proper format. And then Junos has some issue. Let's wait for Arista. Arista is also okay, but output is in the different format. So let's provide this error to the chat GPT. So we'll ask, please provide us the ping output same as routers output plus this error. So let's see. So this is the information. It shows what changes it has made and what exactly you need to do. So I need to change the connection type as a network CLI. So let me copy this code, paste it here, and then change the connection type as a network CLI. So let's try to rerun this program. It looks to be good on XR1, XR2. It looks to be good on a Juniper as well. Okay, we got some warnings. Now it is performing the task on the Arista. Yeah, we are good, but it's still displaying in the weird format. So let me ask the ChatGPT again. Display the ping output same as router output. So it should provide us the new program with this some modification. So these are the changes in the new playbook. So let's try to copy, paste and rerun. Looks good on XR devices. And it should display the output now in the second task. So this is the for playbook. This is showing for task. Here is the ping output for one. This is for two. This is for three on both the devices. This is for four on the XR1 and XR2. This is on the Junos. So we can remove this information by asking ChatGPT to please provide the clean output. So it's okay with the Juniper. Now it is running on the Arista. And we are good with the Arista as well. So you can see here it is showing the ping result for all the prefixes. For that one, for R3, and this is for its own Juniper device. This is how we can test the connectivity. We can clean this output is asked by asking the ChatGPT, and we can just ask the ChatGPT to just show the ping information here, only relevant information here. So we can still modify the program, but now it's okay. So this is it for the connectivity test, and now the last task is to back up all those configurations. So let me ask to the ChatGPT, please provide me Ansible playbook to back up the configuration on RSVP-frr Juniper Arista devices. Below is the inventory file information. Just copying the inventory file information and providing to the ChatGPT as the input. Let's see how ChatGPT reacts on this. Let's copy this code and paste it as a new file, backup config.yml. Let's paste it here and let's try to run it. Let's let me rename it as a backup. Okay. We didn't get the backup for Juno, so let's see. We didn't get the output from the Junos as well as Ansible. And then let's ask the both the information to the ChatGPT plus privilege S. So let's see how ChatGPT reacts here. So for the Juniper, we need to use the netcom. And for the arista, we need to ensure that enable become pass parameter has been passed. So let's see the Junos first. So let's change it to netcon. We are good. So let's check for the arista now. So it's asking Ansible become method enable. So let's copy this particular parameter and let's paste it here. Already we have provided the enable password here. So we should be good. Let's save it and let's try to rerun it. We are good with the XR1 and XR2. Good with the Junos now. Okay, so we are still getting some privilege in issue on the Arista. Let's check again with the ChatGPT. So just try to copy and paste all the Ansible related stuff and let's see. So this is the change here. So here backup is so he has added the become method here. So now let's see if it can resolve our issue for the Arista. Let me delete all this file. Yes, done. Let's see. Let's rerun the program. But XR1, XR2 is good. Junos is good. Yeah, we are good with the Arista as well. Good, so we can verify. This is the backup configuration for XR1. This is the backup configuration for XR2. This is the backup configuration for the Arista. And this is the display set configuration for the Juniper. This is how we can automate our networking related task using the Ansible and then ChatGPT. Even if you don't know ABCD of the automation, nothing to worry. So you can take help of the ChatGPT and you can automate any task. So in today's session, we saw the OSPF configuration using the Ansible and ChatGPT on the Juniper. Then in the task 2, we verified the OSPF neighborship on all 4 devices. Then in the task 3, we verified the connectivity, and in the task 4, we backed up all the configuration for all those devices. And that's it for today's session. And thank you very much for watching. And